So just as I discussed on the board, there's two different ways to measure an angle. We can measure it in degrees. We could also measure it in radians. So just like we convert something from centimeters to inches, or convert something from Canadian dollars to American dollars, we can also convert from degrees into radians. And here's the formula for it. 1 degree is worth pi over 180 degrees radian, pi over 180 radians. So because that's true, if 1 degree is worth pi over 180 radians, think about it for just 10 seconds. What would 2 degrees be worth?
2 pi over 360.
Close. Okay, I just heard 2 over 2 pi over 360. It's very, very close. If 1 degree is pi over 180 radians, 2 degrees is 2 of those. You don't have to memorize this formula. You get this formula on the exam. And that's how you use it. And that's the answer. Okay? If you have 3 degrees, you have 3 pi over 180 radians. If you have 45 degrees, you have 45 of them. Is that fast? What if you had... All right, continuing on after that brief disturbance. So if you had 120 degrees, you would have 120 of those. And that's it. Well, almost it.
Is that all you do?
No, it's not all you do.
Plug it into the calculator.
Hey, what you should do is use the calculator to reduce it, or reduce it without the calculator, because it's a little impolite to leave it as 2 over 180. Well, let's try to do these reduce things without using the calculator. 2 over 180 is the same as what over what?
Pi over 90.
Right, because you can divide the top and bottom by 2, or use the calculator to reduce the fraction for you. So that's exactly equal to 1 pi over 90. Okay, for question B, 3 over 180 is the same thing as 1 over 60, or 1 pi over 60. 45 over 180. You can reduce that in your head. How many times does 45 go into 180? 4 times, so that's pi over 4. Now look, I know reducing fractions isn't exactly everybody's game, so you could actually type this into the calculator and do it for me too. Okay, off your devices, unless you're using the calculator. 45 over 180, do you know how to reduce that on the calculator?
180 divided by 45.
To reduce this on the calculator, you just type in 45 divided by 180, and then to reduce it to a fraction, you press what button next?
Math.
You press the math button,
1.
and then you hit the enter button twice. So if you're reducing fractions, you can do them in your head if you feel good about them. But if you don't feel good about reducing the fractions in your head, you can use the graphing calculator to reduce the fraction quickly. So 45 over 180 is the same thing as pi over 4, 1 pi over 4, 1/4. So you get 1 pi over 4. And then how about 120 over 180?
2 pi over 3.
Okay, you could reduce that on the calculator or by just using your brain that way, if you feel good about it. But use the calculator if you need to. So when we change things from degrees to radians, I hate to say it this way, but it makes things look uglier. Right? When we go the other way, it makes things maybe more beautiful to us. Well, I wouldn't maybe use, I changed my mind. I don't want to say it makes things uglier. It makes things
Worse.
Well, it makes things look different than we're used to. Okay, a 2-degree angle is really, really small. I mean, after a while, maybe work on this, you understand that pi over 90 radians is actually also very, very small.
That's right, you're covering the microphone.
Oh.
Oh, is that one of the, it's one of the older iPads?
Oh, maybe I am. Okay. All right, how about going the other way around? You don't have to memorize that formula. It's given to you on the test. So 1 radian is worth 180 over pi degrees. So all we have to do is drop in that fraction next to it, just like we did the other, on the questions just above. So all you gotta do is drop that down next to each one, making sure you take some good notes here so you have something to walk away with, and that's it, that's the answer. Well, you should reduce that. What happens with the pies?
They cancel out?
Yeah, we're not cross multiplying because we're multiplying the fractions together. So you're not going to multiply pi times pi. You're just going to multiply these two together and multiply these two together. But if you've got a pi divided by a pi, as you heard, those just drop out and get eliminated. And 180 divided by 3 is 60 degrees. Do you see what happened there? We went from something strange to something more familiar. And it's really quick. It's really quick to do. Unfortunately, we don't have a lot of time to practice this year. Just on the homework tonight and maybe in a couple review questions as they turn up. But you do have the conversions on the test. So if I've got pi over 6 radians and I want to make degrees out of it, all I got to do is pop in 180 over pi. And what's going to happen with the pi's?
Cancel out.
Yeah, they disappear because pi divided by pi is 1. 180 divided by 6
30.
just comes out to be 30 degrees. So we are doing some, maybe I call it upper level math. You know, this is algebra 2, pre-calculus and calculus sort of work here in geometry. So 3 pi over 4, you just fit in the 180 over the pi. And one thing you should be noticing is every time we do these, every time we make these changes, the pi's end up disappearing. Which I guess would be the weird part about it, is the fact that there's pi's there to begin with.
So is the 3 pi just gonna go?
Well, just the pi gets eliminated. The 3's still there. So 3 times 180 divided by 4. So 3 times 180
540.
divided it by 4
135.
gives you 135 degrees.
And
And then if you just had pi radians,
180.
that ends up being 180 over pi times pi. The pi's disappear, so all you're left with is 180 degrees. So just as I said moments ago, when you convert to radians, usually a pi appears. When you convert to degrees, usually the pi disappears. I think we're only going to do one more question. Yeah, we're only going to do one more question, I think, and then move on to going over the homework. All right, so let's look on to, just to speed things up. Let's take a look at, all right, so this is a good choice for one to kind of wrap things up with, because they're looking for the arc length, and you can see they gave us a pretty crummy measurement there, 5 pi over 6 radians. So one way to work this question out is to do what? If we're looking for how long it is here, what's kind of on our way? Right, so the big problem with this question is that this is not measured in degrees. So to make the question easier, we're going to turn it into degrees. We'll do that right inside. So if you have 5 pi over 6 radians, look at the work that we just did. What do we multiply that by to get rid of the radians? Yes. Usually when we convert to degrees, the radians will disappear. And that means the pi would disappear. The pi's cancel out. 5 times 180 divided by 6 would be 150 degrees. So that's a quick conversion. Figure out that the central angle is worth 150. And Now we can do the work that we did yesterday to figure out the arc length. Still paying good attention? Okay, so we did all that work to get the angle right. Now let's use the formula from the last few days to work on figuring out how long it is. So the formula we've been using to figure these things out would be the angle over 360 divided by 360 equals part over the total. So in this question, what's going to be in the top left-hand corner? The angle. The bottom's going to still be 360. And what's going to go on the top there? X, because we're looking for part of the circle. And then what's the total going to be? The area or the circumference? Okay. And why circumference?
It's not looking for like the whole thing, it's just looking for the arc.
Yeah, we're looking for the arc length. We're looking for part of the length of the circle. So the part would be the length that we're looking for, and the total would be the total distance around that circle if it was a full circle. So we're going to use pi times d on the bottom, which would be pi times what number?
16.
That's it, 16. If the radius is 8, the diameter would be 16. And then let's just cross multiplying to finish these things off. I would say that that's about as complicated as you'll get, almost as complicated as you possibly could get on the final exam. All right, let's finish this off. So we get 360 times x when we cross multiply. And help me out with the arithmetic. 150 times 16. We'll just leave the pi in there for now. So 150 times 16.
2400.
So 2400 times pi. And then we're one step away to figure out how long it is on the circle. Divide by 360. And you get x is about,
6.6, and like it goes on.
so it's 6.6 repeating times the pi. The directions say, write your answer. No, it just says it says write your answer to the nearest tenth.
6.7.
So what you want to do is multiply those together then and round it. So the answer is about 20.9 when you. So 6.6 repeating. 6666666 times pi would be about 20.9 centimeters or whatever, however it's measured, for how long it is on the circle.